Okay, well, really fast. Thanks for the invitation. And what we're going to do today is I'm going to kind of set the science table for everyone and then invite Sheri to tell us a bit about how we've moved from data to action in Richmond, Virginia. You can find us both tweeting mostly at each other on Twitter via those two handles if you want to keep up with the conversation that we've been having in Richmond for the last several years. So we all know the threat that climate change poses. Climate change is the direct result of the accumulation of heat-trapping gases like carbon dioxide in the atmosphere due to the burning of fossil fuels for human activities like producing energy. And here in the United States, really getting us around from place to place. The largest source of carbon emissions from people in Virginia is in our transportation system. And this has the effect of warming up our global climate. We've seen about a 1 degree Celsius increase in temperature over the last century or so. Most of it happening in the last 30 or 40 years. In fact, this visualization does a very good job of expressing that rapid change here, with the farthest left being 1850 and the far right being the relative present. This is the famous warming stripes visualization, where each bar is a year and the color corresponds to how weird that temperature was versus the 20th century average, with blues being colder than expected and red being warmer than expected. You would have to be 34 years old or older to have lived on the planet the last time monthly global temperatures were below the 20th century average. So virtually everyone under the age of 35 has grown up in a world that has been progressively, in many ways, getting warmer and warmer. This trend is expected to continue for as long as humans remain a primary source of carbon dioxide to the atmosphere, which is intensifying the planet's natural greenhouse gas effect. Now, what does climate change mean to us as an impact, especially here in the mid-Atlantic, where we live? We're already experiencing and expecting a continuation of a hotter, wetter, sneezier, and wheezier climate. We'll talk a lot more about hotter for the remaining time today and its overlap with urban heat islands. But very quickly, climate change in the mid-Atlantic region and throughout most of the Southeast and the East, more broadly here in the United States, is centered on a wetter climate. And now this means more extreme precipitation events or more rain falling in the same or shorter durations of time than in the past. This, of course, has a huge impact on our sewer systems, quickly overwhelming our drainage basins and causing the really dramatic flooding that we've seen impact many communities around the country recently. Now, also wetter in the sense that the eastern United States and every coastline around the United States, regardless of place, will have to deal with increasingly high sea level change over the next few decades. And the total amount of those impacts is directly related to how long humans continue to allow global warming to continue. For every degree of additional warming, these impacts continue to increase. And then here on the righter side, this sneezier and wheezier is kind of the integrated result of changes to our seasons. The sneezier idea here being that our pollen seasons are longer and more intense, and the wheezier climate being things like wildfire smoke having an impact on our local air quality. But we'll get back to that. Let's go into the hotter thing a little bit. You may have heard recently from increased coverage of this topic, but in case you haven't, extreme heat is actually the leading cause of weather-related fatalities in the United States. Even more so than those really charismatic storms like floods, tornadoes, and hurricanes. And I think that this is somewhat of a crisis of communication. Hurricanes and tornadoes and floods are very explicit in time and space. We can watch them on TV as a hurricane traverses the Atlantic Ocean, as we're probably going to have to do here in the next few weeks as hurricane season really wraps up or ratchets up. Extreme heat, on the other hand, is very diffuse in place and in time, with places within the same region having different thresholds for what is considered extreme heat. Different response plans at different municipal and jurisdictional scales having difficulty communicating the impacts or how to prepare for an extreme heat wave. And so these events are much harder to communicate the risks around than something like a discrete kind of effect like a hurricane or a tornado. And we know that this has damaging and considerable effects on human health here in the United States. We learned this in very dramatic fashion as part of the heat wave that hit the city of Chicago, Illinois, back in the 1995, the summer of 1995, where not only did 750 people die, depending on the estimate, around 750 people. But we know now from Eric Kleinenberg's work, which is published in a book called Heat Wave, that many of these folks were elderly members of communities of color on the southwestern side of Chicago, which have a very clear history of disinvestment and social fractionation and marginalization, and lack of inclusion in governance structures, and disinvestment in the form of a variety of forms of generational wealth building. Now, this is something that we know has repeated itself. We just saw this exact same kind of pattern play out last summer in the Pacific Northwest, where it was mostly elderly members of communities of color that didn't have adequate cooling and ventilation in their homes, succumbing to those very dangerous and historic heat wave conditions. Now, within human settlements, we know that heat doesn't express itself the same way either. Much like the impacts are disproportionate, the physics are disproportionate. And I want you to think in your head, if we were going to invite you to go on a scavenger hunt in this picture for the hottest place to the touch, where would you go? At the same time, where would you go to see the coolest spot to the touch? We can assess that with a tool like an infrared camera, which shows you the surface temperatures of all those different land use types, land cover types in this picture. And here we see the brighter colors as the hotter surfaces, and the darker colors as the cooler surfaces, or the cooler temperatures. Now, the asphalt, by far the hottest thing, has by far the lowest albedo, or reflective ability for the sun's incoming radiation. It then absorbs that incoming radiation and re-emits it back out into the environment as heat throughout the afternoon and into the evening. On the flip side, the coolest place is by far in the trees, in the shade. There's probably 60, 70 degree difference to the surface temperatures between these two places, but everything in between is really interesting as well. The colors of the cars, the types of vegetation. We see this non-native European grass versus these native Central Virginia plants that have much deeper tap roots that allows them to transpire deeper sources of groundwater. And then, actually interesting here, the dried, desiccated, non-native grasses can be as hot as the sidewalk right next to them. So we can see just how vegetation itself can actually act like a heat amplification mechanism. Now, we know this feature of our cities. It's called the urban heat island effect. It's been studied for over 100 years. In the last 40 or 50 years, the research has really kicked up. And a few years ago, a colleague of mine, Vivek Chandas, and I developed a community science or volunteer-based assessment method for urban heat islands, where we recruit local organizations that represent the needs and serve community members in our city to co-develop a methodology for how to assess where the hottest places are in our city. And Groundwork RVA, which is part of the Groundwork USA network, which I know many of the USDA and the Forest Service folks know about through their work in urban and community forestry. They participated in the campaign, as well as university partners, city partners, and the Science Museum of Virginia at the kind of nexus point of this. And through this community science approach, we were able to discover a 16 degree Fahrenheit difference between the coolest and warmest place at the exact same time on the same day during a heat wave. We've been working now on the health impacts of this pattern of extreme heat. But first I'll explain some of the coolest places in the city, by far the most forested. Some of the hottest parts of the city are those with the widest streets and the shortest buildings and the fewest trees. In fact, when we were looking in the downtown urban core, where many people expect to find the hottest temperatures, that's where we found the shading effect from variable height buildings was actually improving the thermal experience. Whereas it was very short buildings, very wide streets, and very limited tree canopy define the warmest places. And when we look at what these warmest places look like through the lens of health, using data from the Richmond Ambulance Authority, we can see that there's a disproportionate amount and rate of heat-related illness responses from the ambulance in these hotter areas, even correcting for things like the population density. This relationship holds. So we see there's a difference in the health impact of this heat, depending on where you are in the city. We also know that this is an environmental justice issue, whereby Black residents of the city represent a disproportionate amount of the total cases for heat-related illnesses responded to by the Ambulance Authority, and white residents are underrepresented. So, but even though they have about the same percentage of the Richmond population. And when we're looking at what's going on so far this year, I wanted to mention the VDH and many state agencies, including the National Integrated Heat Health Information System, operates heat.gov, which you can go to and look at national patterns of heat-related illnesses. So far this year, we've had over 2,500 heat-related illnesses in 2022, predominantly in males and predominantly younger in age than some people tend to think of. Now, part of the interesting question I think to ask about the data that we found in Richmond was how did we get here? How did we come to have this huge difference in temperatures disproportionately impacting individuals of color in the city? We found the exact same patterns when we replicated our community science model in Baltimore and Portland and Tacoma and a few other cities around the country. We've consistently found this pattern. A unifying concept that helped us explain this variation were the redlining maps of the 1930s. If you haven't heard of this, it was a New Deal program meant to stabilize the housing market by allowing federal assessors to go out into neighborhoods in 250 cities nationwide and rate them for their perceived safety for financial investment in the form of things like mortgages, mortgage insurance. And so what these assessors did, walk around their city and draw polygons around existing neighborhoods and then assign them a grade. And much like your grades in school, the lower the grade, the worse that neighborhood was perceived to be for investment. So much so that the red polygons were almost wholesale denied access to particular forms of wealth building investment for home ownership and land ownership. Now, this gave rise to the idea of redlining. Now, this was supposed to be based on an objective way of assessing their safety for investment, but it was really based on the color of the skin of the folks that were living there, and the class and the immigrant status of those people. So we know disproportionately high rates of neighborhoods with high Black populations, immigrant populations, and Asian populations were assigned redlined designations around the country, whereby A-rated or the green line neighborhoods were almost predominantly wealthy white communities at the time, and even remain so to this day. Now, we wanted to ask the question, how does this well-known effect on the socioeconomic status of our cities in the present day through these redlining studies in the economics literature, how does this relate to the findings that we had about extreme heat? And this was featured in the New York Times. Our paper was published in January 2020 in the journal Climate. And the New York Times highlighted it, showing that when we look through the lens of this redlining map at the present day expression of extreme heat, we see these formerly redlined neighborhoods tend to be much hotter than their non-redlined counterparts, while having way more paved surfaces, way more imperviousness, those same surfaces that you saw in that heat photo. amplifying those temperatures, and many fewer trees, which is super important to the lens of community and urban forestry. Now, when we zoomed out to all of the cities in the redlining database, 250 cities around the country, 94% of the cities had the exact same pattern. There were some regional differences. Some of the largest differences we found were in southeastern cities throughout the Southeast. Now, other studies since that, our kind of first study in 2020, have linked redlining with differences in air quality. So a sneezier and wheezier climate, extreme precipitation and flooding, a wetter climate, and many other related adverse health outcomes, including gun violence and COVID-19. And so and even if your city wasn't redlined, there was a study that was published last year in 2021 that showed that these patterns exist in 71% of all US counties. There is a disparity in heat along racial and income related lines. So the wealthier and whiter you are, the less exposure you have to extreme heat. So what I hope that I've shown you through this is that we've established that our own neighbors in our own cities are already experiencing a hotter, wetter, sneezier, and wheezier climate. And this is largely due and can be linked directly with the integrated impact of urban planning decisions, redlining and otherwise, because it didn't stop with redlining. It continued with things like urban renewal, the interstate highway system, bulldozing entire redlined neighborhoods such as Jackson Ward here in the city of Richmond. And the present day is the integrated result of all of those decisions that have largely left those residents either intentionally or unintentionally out of the process of deciding the future of their own neighborhoods. And so community-driven solutions are going to have the most civic legitimacy as we move forward and ultimately prepare us for the additive effects of climate change on things like housing, food, and other infrastructural struggles. Now, as far as what we can be doing to address urban heat in our cities, this is a really good and free resource available to everyone on this call. Lad Keith and Sarah Merow published the Planning for Urban Heat Resilience through the American Planning Association, I believe, and they broke down our solutions basically into two categories: heat mitigation, or physically turning down the thermostat on heat. So this would be things like nature-based solutions that we'll get to about our work here in Richmond, and then heat management, and that's really the governance structures that prepare and respond to the acute heat risk, things like early warning systems and emergencies. It takes both of those approaches to really truly produce a heat resilient community. And I like to say that while we have this whole menu of options in front of us, some cities are focusing just on one thing. They have an entire menu and they have an entire buffet, but they're only eating one thing on the buffet instead of sampling all of it. And that's what it's really going to take for us to move our cities from being so disparate in heat and climate related impacts to things that will be much more comfortable and sustainable as we approach the decades to come and the threats that climate change pose. So what I want to do now is invite my colleague Sheri to join us to share with the group here what we've done and what she's been largely in many ways responsible for in a few cases, what we've been doing with the data here in Richmond. So please, Sheri, do you want to pop on and get us going on that?